The diagram on the right shows a semicircle A, B, C, D, E with center F, and B, G, D, F is a rhombus. So this is B, G, D, F. This is a rhombus so that we know all the sides here having the same length. This is one of the properties of rhombus. This is given that the coordinate of E, F, and G are 9,6, 5,6, and 5,8 respectively. And angle BFD is equal to theta radian. Calculate the value of theta in radian. Okay, before start solving this question, let's do a quick revision for this one first. When we are given the coordinates of few points, how do we find the distance between the 2 points? I think you still remember, right? The formula that we use to find the distance between 2 points is x2 minus x1 square plus y2 minus y1 square, and then we square root the whole thing like this. Okay, but actually we don't have to always use this formula. When we are asked to find the distance between 2 points, we try to observe their coordinate first. Now let's look at this example. What is the coordinate of A? It's 2, 5, right? 2, 5. How about C? 6, 5. 6, 5. How about B? 2, 2. And how about D? 5, 1. Now let's say if I ask you to find the distance between point A and point C, do we need to use this formula? If you want to use this formula, it's okay, but here we actually don't have to use the formula. Now try to observe their coordinate. If they have the same y coordinate, we find the difference of their x coordinate. If they're having the same y coordinate, means that they are horizontal like this. So we want to find the distance between these 2 points, just find the difference between their x coordinates. Take the larger value minus the smaller value. So in this situation will be 6 minus 2, 6 minus 2, which is equal to 4 units. Right, you can count 1, 2, 3, 4. Okay, so how about if I ask you to find the distance between point A and point B? Again, we try to observe their coordinate. If they have the same y coordinate, we find the difference of their x coordinate. If they have the same x coordinate, we find the difference of their y coordinate. In this situation, their x coordinate are the same. It means that these 2 points are vertically like this. We find the distance between, we find the difference between their y coordinate, which is 5 minus 2. 5 minus 2 is equal to 3 units. You can count 1, 2, 3. Okay, this is the way how we find the distance between 2 points. So how about if the question asks us to find the distance between point A and point D? Now again, try to observe their coordinates. This is 2, this is 5, difference x coordinate. How about y coordinate? This is 5, this is 1, difference y coordinate as well. So in these situations, they have the same, they have the difference x coordinate and difference y coordinate. So like this, if you see the situation like this, we need to use the formula. So how do we use the formula? X2 minus x1 square plus y2 minus y1 square, and then square the whole thing. So you might be asking, so how do I know which one is y? X2, 5 minus 2 or 2 minus 5? This is totally up to you because you have a square over here. 5 minus 2 and 2 minus 5, if you square it, you get the same thing, right? Okay, I just use 5 minus 2 square plus, again, for the y coordinate here, you can take 1 minus 5 or 5 minus 1. If you square it, you get the same thing for both. Okay, let me just use 1 minus 5 square. Square root the whole thing. So this 3 square, you will get 9. This is negative 4 square, you get 16. Add up these two numbers together, you get 25. Square root of 25 is equal to square root of 25 is equal to 5 units. Okay, now this is a way how do we find the distance between 2 points. Okay, same thing apply here. For the first part, we want to find the value of theta in radian. Can I know the distance here? How do I know the distance here? As I told just now, Now we are given the coordinate of F and the coordinate of E. So can we find their distance? Yes, right? Try to observe their coordinate. Same y coordinate. Therefore, if you want to find the distance between these 2 points, find the difference of their x coordinate. So from here I know that the EF is actually 9 minus 5, which is equal to 4 units. So this is 4. If this is 4, here will be 4 as well. All here will be 4. Right? How do I know here also 4? Because this is the radius of the circle, right? This is the radius of the semicircle. Here also the radius of the semicircle. If this is 4, here will be 4 as well. Okay? Now, how do I know the distance between FG? Again, try to observe their coordinate. Same x coordinate. Therefore, we find the difference between the y coordinate. So GF is equal to 8 minus 6, which is equal to 2 units. Here's 2 units. Now, why do I want to find the distance between GF and DF? Okay, can you see a triangle over here? Now I have a right angle triangle over here. This is the same GD and FD having the same length, right? Right? So when you draw a line, like go down like this perpendicular to FG, we know that these two must be having the same length, which is 1 and 1. Now, can you use trigonometric ratio to help you to get the angle here? Okay, let angle DFG BX. Okay, so cosine x is equal to CAH. So remember CAH, adjacent divided by the hypotenuse. So how do we find x? We just find the cosine inverse of 1 over 4. Okay, just press your calculator. Okay, let me show you how to press it. So press shift first, shift, and then cosine. Just key in 1 over 4. Okay, 75.52. 75.52 degree. So the angle here and the angle here, they are the same, right? These two triangles, FGD and FGB, they are congruent. Okay, so this angle and this angle are the same. Now, theta is equal to 2 times 75.52 degree. Okay, so theta is equal to 2 times 75.52, which is equal to 151.04 degree. But the question asks us to give the data in radian. Okay, let's convert it to radian. 151.04 times, no pi is given here, so I will assume that the pi is 3.142. 3.142 divided by 180. Okay, now this is radian. 151.04 times 3.142 divided by 180. Okay, let me just round off it to correct it to 4 significant figures. So the answer will be 2.636 radian. Okay, this is the answer for part A. Now let's go to part B. We want to find the area of sector BFD in square unit. So BFD is over here. We want to find the area here. So here I'm going to use a formula. Still remember this: area of sector 1 over 2 r squared theta. If you are using this formula, the data must be in radian. Okay, area of sector BFD 1 over 2 r squared. What is r? R is equal to 4 times theta. Theta must be in radian, which is 2.636. Okay, just press your calculator. 1 over 2 times 4 squared times 2.636. Okay, 21.09. 21.09 square unit. Okay, this is the answer for part B. Now let's try the last part. We want to find the area of the shaded regions in square units. So it means that we want to take the area that we got just now, which is area of sector BFD, minus the area of the rhombus here. Okay, let me draw a triangle over here. Let me draw. Now, still remember just what I told you, these two triangles, they are congruent. So if you can find the area of one triangle, you times 2, you will get the area of the whole rhombus. So still remember what we got just now, the angle here, this is 75.52 degree, we got it just now, right? And this is 4, here also 4, and this is 2. Now, how do we find the area of this triangle? Area, this is for part C, area of triangle GFD 1 over 2 times 2 times 4 times sine 75.52. Still remember, you learned this in Form 4 solution of triangle. 1 over 2 times 2 times 4 times sine 75.52. Okay, 3.8729. Now, so if I want to find the area of this rhombus, I just need to use this one times 2. Area of the shaded region is equal to the area of this sector, which is 21.09 minus 2 times this. 2 times this. Okay, just press your calculator. Okay, let me just correct it to 4 significant figures. It's equal to 13.34 square unit.